Bye.
Cheers, Julie. Thank you.
Thank you, Miss. See you tomorrow.
Okay.
Is Julie home?
Home.
She hasn't even cleaned my room. She hasn't swept, she hasn't taken a cup out of there, she hasn't done anything in my room. No, I'm not cleaning it there.
Leave it.
No, that's
So
fucked
that's
up.
her.
Just... No, man.
Maybe if you were in there the whole day.
I wasn't. I've been awake since 8 o'clock. I've been out, I ate food in here when Tutti was eating in here. No. She's just fucking lazy and doesn't want to do it.
Yeah. Just leave it like that. She doesn't do it tomorrow.
To go home at 2 o'clock when she only got here at probably 9 o'clock.
3 o'clock now, I'm going now. No. She just armed and it's till 3. It's very bad one.
She hasn't even taken wash the cup.
Sure. Hi, Modulator. I'm just waiting for people to join the stream. I had a problem this morning. Afternoon, Asafika. Let's just give the guys some time to get in. Take it off her, please.
Yeah, you get to clean up more of a mess tomorrow.
Right, I'm going to give him 5 more minutes and then I'm going to start. They do have the link. It is recording on YouTube anyway, so they can always refer back to it. Hi, Rito. Are you back at Res yet?
I'm making a mess for you. No.
Kelly, I'm on camera.
It's not my problem. She cleaned every single other room except for mine. For what? Not like I wasn't in there or I was sitting in there the whole day. She didn't.
No problem, Rito. We've postponed it till the 12th. Because today I basically just want to do the energy behind it. Then sometime next week I will do electricity because I actually want to show you how it is built on a breadboard. I'm going to main campus to see what I can go and get on main campus tomorrow, if anybody's around, because I believe there's no electricity. Right, so let's start because it's already 6 minutes past now. Right, people, we sorry, we had a big problem at Sebeking campus this morning. I don't know why. The Wi-Fi said it was full, but the Go Live chat where I normally chat with you in the classroom was just turning and turning and turning and just saying go live, go live, go live. So I don't know whether the signal wasn't strong enough at Sebeking, so that's why I came back home, because at least I know my signal is quite strong here. But I will reschedule that education meeting with you guys at some stage. I will ask Boy Secretary when it best suits you guys. People, unfortunately, I haven't started marking the NS Test 1 yet. The external moderators from the postgraduate diploma have sent back our stuff, and we are now busy at this stage putting in 250 students' marks, and we are doing the final calculations on those marks as they have to be handed into the exams office by tonight. So we are working frantically to do that. Please also remember that I'm also constantly in meetings with Dr. Chris. I sit on many research committees. So I'm not just sitting around not marking, I promise you. I have started. Please don't panic. You guys are not doing badly at all, especially with the education side. I haven't started the first NS one yet. But on the education side, I think the lowest mark that I've got so far is 80. I captured all the other marks. I've just got the last about 50 to do. But I am going into main campus tomorrow. I do have a problem with my computer. It's very, very slow at the moment. And it needs to be upgraded. Now, there's nobody at Sebeking that can upgrade the computer. So I'm going on to main campus tomorrow to see if I can get the upgrades that I need. Right, so I'm going to talk about the Energy 9. As you see, you will see in your notes, I did send you through the notes, right, on energy, that it makes up your entire universe, and it's on the concept mostly is central to all science is energy. We talk about potential energy, we talk about kinetic energy, heat energy, sound energy, wave energy, radiation, etc. That is all types of energies. Right. Anything that occupies a space will have energy. All right. And energy, remember, now this is what I wanted you to do for your roller coasters, is what is most important is that energy cannot be created and it cannot be destroyed. It can only be transferred from one form to the other, okay? If you think that you go and boil water, what happens to it? First of all, it will become heat energy, and if you boil it for long enough, then that heat rises into steam, okay? So that's another sort of side of energy. But if you looked at my notes before we got into the lecture, then you will see there are all sorts of energies. We get energy from the sun. We should know that. All right, photosynthesis and etc. cannot happen without the sun. We also have nuclear energy, as we know, and we also have geothermal, which is your geographical power, okay? In geothermal, we also talk about energy that runs underground, etc. You also have hydroelectric energy. That is energy that runs through water wheels. You can actually generate electricity from water, okay? You can generate electricity from wind turbines. All right, and I've spoken about photosynthesis. And then if you use that energy for a long period of time, okay, like things like petrol, okay, which is petroleum oil, and natural gases, and things like coals, which are fossil fuels. Those are reusable energy sources. Okay, energy from the sun. We've all heard about solar paneling. That can be converted into electrical energy, so you can capture that energy from the sun with solar panels on your roof, and you use that energy to cook, etc. Right. And we've spoken now about wind energy. I'm sure you've done all of this at school. Okay. Nuclear fuels can also be used to make energy. All right, so basically, the energy comes from all sorts of different sources. You can go through the notes as you like, okay? There's all different types of energies. When you throw something up and it comes back down, we talk about gravitational energy, and you guys know it as little g, and I think you used to using it as 10, but the actual figure for that is 9,81. Okay, remember, it's the acceleration due to gravity, the thing that holds you on the earth. You get chemical potential energy, right? Energy that is stored in batteries, lithium cells, like in your cell phones, etc. And of course, you get electrical potential energy. You all work with that. Hopefully, you've got electricity at RES. You also get then mechanical energy. Some of you guys that are doing mechanics will know mechanical energy, you get electrical energy, heat energy, and the most important ones that you need to know at the moment is kinetic energy and potential energy. Now, remember the equation for potential energy. That means something has the potential to move, okay? So it's sitting on a point, but it could move or be transferred into another type of energy. And that is the result of it sitting in the place that it is sitting. And the equation for that is EP equals mgh. So it's a result of its mass and how high it is, and of course, its gravitational pull towards the earth. When we talk about kinetic energy, we're talking about the energy that is used as we move. If something moves, there we also use a half EK equals a half mv squared. So that has to do with how fast it's moving, all right? And then obviously also the mass of the object. Now, the whole thing with the conservation of energy, right? You'll see I've also given you exercises to do there. I will give you the answers to those exercises. Unfortunately, they're still sitting at Sebeking at the moment. I'll have to scan them for you. I will be back on campus next week anyway. The main thing that you have to remember, people, is that the energy that you have before something rolls down a slope, or like your roller coaster that you're building, that energy is not created. It is already there. It is just stored potential energy. And the energy that it has as it starts moving must be the same as the energy when it rolls down your roller coaster and it then eventually will stop. Okay, so the energy before must be equal to the energy afterwards. Right, that's the most important thing that you have to remember. So your equation will basically, I think I have given you examples. I've done potential energy there. There is the energy before must be equal to the energy after. You'll see the equations. I've given you quite a good background there. And I'm just scrolling down to see, there we go. You can see the main equation that you people are going to be using or explaining to me when we actually do the class is the presentation of the roller coaster is that the energy before is actually equal to the energy at the end. So it's the law of conservation of energy. You cannot create it and you cannot destroy it. You can only merely transform it from one type to another. Right. So as you can see there are quite a few little exercises for you guys to do. I know that you have done this in, I think it was either grade 11 or grade 12. So it is nothing new to you at all. But what I'm going to be looking at on the 12th, that's what I wanted to speak to you because it's quite a big presentation and it's worth quite a few marks, is please make sure that your roller coaster is sturdy. When we were deliberating about the date of the roller coaster, a lot was saying it's going to fall. That roller coaster must never fall. If it falls, you will lose marks for sure. Okay, so that's why I've given you the extra time. If you can work in groups, please do. The other guys, you will have to, on the group, send me your cell phone numbers, those guys that are at home, and we'll WhatsApp video call you on the day that we are doing it. I am going to mark you on the presentation that you give exactly as to what is happening. I want you to mention, obviously, the conservation of energy, the law, right? If you want to, you can very cleverly go and measure the mass of your car and the height of your roller coaster and see if you can quickly time it. These cell phones, our smartphones are so good these days, and see whether you have conserved the energy before must be equal to the energy at the end. That would be even better. I'm going to mark you on that presentation. I'm going to mark you on whether the ball actually, or the car, or whatever you have actually did roll down your roller coaster. It's no use building a roller coaster and nothing can go through it, okay? So number one, it has to be very, very sturdy. That's when I said you can even go and walk around and get a piece of chipboard or whatever and build it onto there, but make sure that the thing is secure. Don't give me a flippy, floppy cardboard thing because immediately I'm going to put my foot on it and it's going to break. Right. So what I'm saying to you basically is that you need to explain it to me, and you need to explain the science behind it to me, okay? I'm trying to do things with you that you can practically go in. Let's say that next year you guys, I doubt that COVID is over and that you can go into the schools, that you can go and teach them these sort of things and they can also do it. That's why I'm trying to make this as practical as possible for you, so that when your mentor walks out of class the day that you arrive at school, you at least can handle practical classes, right, and the theory behind it. Okay, so what we'll do is I will definitely see you on the 12th at 10 o'clock. I will be at Sebokeng campus at the res there. The guys from Amberfield, Pasha has rearranged the bus for you. You have permits. Apparently, they have been sent to your VUT emails. Okay, so you'll just have to show the guys at the residence, and we will do it in the parking lot at the residence. I will be standing there with my rubrics ready. I will probably send out the 12s, okay, so that you can actually see what I am looking for. Or people, my internet, they're saying that the connection is very unstable. I think it's got something to do with the weather and the power outages and things. So basically, that is basically all you need to know about energy. Okay. As I said, I'm not going to test you on it, but there are some exercises there for you to practice on. I will give you the answers to those when I scan them back at Sebakeng. Right, which I will be back next week. So on the 12th, I will definitely scan the answers in for you. Please just hang tight in there with as far as the marking is concerned. Our big concern, as I've said now before, is the postgraduate students. Their semester 1 marks have just come back from external moderators, and there are 250 of those students that we have to physically put in the marks ourselves. So it takes forever. So I have started education. I'm then going to move on to your natural science as well. Okay, I think that test was pretty easy anyway. It was force diagrams. And then the next thing that we'll go on to will be in the next week will be electricity. But in the meantime, I do have breadboards here. I don't know if you guys know what breadboards are. They're the little boards that you plug little resistors into, that you use basically in electrical 1. I know it sounds horrible and it's meant to be natural science, but people, this is part of the syllabus that you will be teaching at school. At school from grade 5 or grade 7 to grade 9, they do electricity. You have to know what a resistor is. You have to know what a cell is or a battery is. You have to know what it is in parallel, whether it is in series, etc., etc., etc. So unfortunately, it is a part of natural sciences. A lot of people complain, oh, we're not doing physics, but physics is a part of natural sciences in primary schools. Ma'am, since, well, we will be doing presentation outside, no PowerPoint. No, don't do a PowerPoint presentation. You're going to speak to me. We'll keep to all the social distancing things. We'll wear our masks because you have to demonstrate to me that your little roller coaster can work. Okay, so there's no PowerPoint presentation needed. No, please, we'll make something else a PowerPoint presentation at some stage. You are going to be speaking to me to show me that you understand what is going on in the law of conservation of energy. That's all. Right, that's why I'm saying to you, I'm trying to make this as practical for you as possible. The guys in pedagogy, I'll also use this mark for you because then at least you can go into schools with these tiny little projects, okay? All right. The next one, as I say, when we get to electricity, I'm first going to be doing electrostatics. Now, I'm giving you a heads up warning. You are going to be building an electroscope for me, right? You will need to keep your mayonnaise jars, you know, any sort of big bottles that you have. You will need to keep the lid as well, please, all right? And all of you will somehow must be cooking on your own and have tinfoil. You'll need tinfoil. The only thing that you are required to find, just go and scrounge around, is a piece of copper wire. And then you are going to go and research on your own how to build an electroscope, okay? And you're going to explain how the charges move. We're going to use a ruler and then see if the little foil leaves repel each other, etc. So that's your next project, okay? So I'm giving you tools that you're going to go out into the schools with when you get into school. All right, people. So I think I've used enough of your data and your time now. I will get back to you as far as the education goes when we can catch up on that lesson. I have sent through the PowerPoint presentation anyway. So long you can go through that, okay? I'm not going to give any education assignments out yet until I have finished marking the second one. Okay. So please don't stress about that. And I promise you, you guys are doing very, very well. So don't stress about education. Okay. And then basically from my side, I've supplied all the information to you. You can see that we'll move into electrostatics and electricity. That will be in the next week. And then our last little part is going to be a part on light. And then the very, very last part that we're going to do is the solar system, because you need to know the solar system. They do it in grade 7, 8, and 9, actually from grade 4 right up. Okay, so we'll do the solar system last, which is a lovely one to do. All right, people, so I'm not going to use your data. You guys have a wonderful afternoon. I will reschedule the same sort of meeting again. Boy, Canelo can just let me know what time, because I'm not sure when everybody else is having class and if there are glitches and etc. But just keep checking your RTS. As I'm marking, I am putting it onto the RTS for you people. I will send a message to the representatives to say, I'm finished marking, go check the RTS. Okay. People, I love you. I'll see you on the 12th. The person that stays in Sasolburg, you must still make an arrangement with me for Vaal Mall, unless you can get to Amberfield and catch the bus from Amberfield, which will be even better for me. All right. And then the guys that are at home, please put on the group that you are still at home with your cell phone number, and I will WhatsApp video call you so that you can also be live and interact with us on the day. Okay, so no PowerPoint presentations for the roller coasters, people. You're going to, if you're at home, you video yourself doing it. We'll be watching you, don't worry. Okay, have a lovely afternoon, guys, and good luck for any tests and things that you have this week. You will be hearing from me shortly again. Okay, I have a lot of meetings this week. I've got the Dean's Education Forum this week. I've got research meetings this week. So things are getting a little bit hectic on my timetable as well. But the wonderful thing is that I actually gave my last postgrad lecture on Friday afternoon. So at least, but the assignments are coming in, 250 of them, madly. But relax, okay? Yes, we will, Brian. We will definitely. I will make sure. I'm going to try and see how many sponsors I can get for this prize. Okay, that's all you're worried about. You don't care about the marks, eh? Okay, people, I'm going to end my stream now. You have a wonderful afternoon. Go and look up energy. If you just go onto the internet, you will see there's lots of roller coasters and things that you can do. Okay, and it will give you ideas. All right. I love you, and I will see you on the 12th, if not before, for education, just to reschedule this morning's lecture. Have a lovely day, guys. Kisses to you, and bye-bye.